Hello guys, let's prove this sum right over here. The sum of squares of the first n natural numbers is n plus 1 into 2n plus 1 by 6. Now I'll be doing two methods to do this. One is the telescopic sum method, which is just pure algebra, and this is not a bar of chocolate, but it's in fact just a rectangle. And we're going to be needing the length and breadth to get this expression. So let me start with the geometrical proof. So for the geometrical proof, I'm going to take n equals to 4. I'm going to rewrite these squares into their numbers. So 1 plus 4 plus 9 plus 16. And here what I'm going to do is represent this number by a dot, this number by crosses, this number by a circle, this number by, let's say, S. And in fact that means I'll have 1 of these dots, 4 of these crosses, 9 of these circles, and 16 of these S's. And right here I'm going to do something kind of weird, kind of just like a why question. I'm going to take 3 of this sum right here. So I'll have 3, 1 plus 4 plus 9 plus 16. So when you distribute that, I have 3 into 1 plus 3 into 4 plus 3 into 9 plus 3 into 16. So what that means is, if I represent these numbers by these symbols, that means over here I'll have 3 of these dots over here. So this dot is multiplication, be careful. This I'll have 3 into 4, which is 12. I'll have 12 crosses, and I'll have 9 into 3, 27 circles, and here 16 into 3, I'll have 48 S's. So I'll have these number of objects to make a kind of a rectangle or any shape to figure out its area and get this over here. So let's see what I can do. I think for the base, I'm going to take one of these dots, 2 of these crosses, 3 of these circles, and 4 of these S's. Why? Because here I'll have 1 plus 2 plus 3 plus 4. And since our 4 is n, that means I have 1 plus 2 plus 3 plus all the way to n, which is just the sum of the first n natural numbers. So this right here is already our n plus 1 by 2. And since I have no space, I'm going to make this a bit nicer, like this over here. And let's see how many of these objects I have remaining. So I'll have 2 dots left, 10 crosses left, and 24 knots or circles left, and 44 S left. So to make a kind of a rectangle, if this is our breadth, then it's fixed. Then that means I have to put these objects on this base right here, and it will kind of layer up. But I'm going to do a quick mathematical step. Instead of just placing down each of these objects like this, counting them, I'm just going to see the total number of objects I have. So that means I'm going to add all of them. So I'll have 12 plus 24, 36 plus 44, which is 80. Then I'll see the number on the base. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'll have 10 as a base. And if I have 80 objects left over, that means I can make exactly 8 layers of 10 over here. So that means I'll have 1, 2, 3, 4, 5, 6, 7, 8. And each of these numbers right here is one object. So that means I'll have a rectangle like this. So I'm going to have a rectangle like this. And for the base, I know it's n plus 1 by 2. But what about for the length? Well, let's see. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. So in fact, I'll have 9 over here, and this is 10. But what is that in terms of n though? We see our n is 4. And what function of n gives us 9? So there is one function, 2n plus 1. This gives us 9. And if you're not sure, what you can do is you can take only 3 of these objects. So that means up to 1 square plus 2 square and 3 square, and do the same method over here, and you'll see that you'll get 2n plus 1, which will be your 2 into 3 plus 1 as 7. So this checks out for the breadth. So from these facts, I will have that the area is n into n plus 1 by 2 into 2n plus 1. And over here, I had taken 3 of this series to make this rectangle. So this becomes 3 into 1 square plus 2 square plus 3 square plus dot dot dot. Since I took n as 4, that will be n square is equals to n plus 1 by 2 into 2n plus 1. And thus divide 3. Therefore, this series 1 square plus 2 square plus 3 square plus dot 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 n square will be equals to n plus 1 2n plus 1 whole by 6. So this is a geometric proof over here. Let's move on to the telescopic sum method. So right here you kind of have to use algebra identity and state that we know this. So we have squares over here, and we want an identity to be in the form of a cube and to power down, and let's see what we can have. So you have to use this identity over here to kind of do a series, and you have to use this identity to prove this formula over here. And if you want to quickly see how we get that, just expand r minus 1 whole cube and just know that you will get this. This number r over here, it can be 1, 2, 3 and so on. So what we're going to do is we'll take each of these cases right here. So when r equals to 1, we'll have 1 cube minus 0 cube is equals to 3 into 1 square minus 3 into 1 plus 1. So when r equals to 2, it is 2 cube plus minus 1 cube equals to 3 into 2 square minus 3 into 2 plus 1. Put r equals to 3, you'll get this, and so on until you're n. So when it's n, it will be n cube minus n minus 1 whole cube is equals to 3n square minus 3 into n plus 1. So now what I'm going to do is I'm actually going to add all of these over here. So when that happens, let's see on the left hand side. This, that, this, that. I'll have 1 cube minus 1 cube. So those will cancel. And 2 cube and 2 cube, these will also cancel. And in the next step, seeing this pattern, I know that and that will cancel. And in the end, I'll know that this right here and that will cancel. And I'll be left with just n cube on the left hand side and on the right hand side. Well, I'll just add each of these terms. So 3 is common from all of these terms. 1 square plus 2 square plus 3 square plus dot 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 n square minus 3 into 1 plus 2 plus 3 plus dot 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 n plus 1 plus 1 plus 1 plus 1. So I'll have n number of ones over here. And as you can see, this over here is our series, what we're trying to find out. So this is 3 into, let's call that Sn for series. 3 into, we know that this sum right here is n plus 1 by 2, and this will be just n. So you just have to simplify from here, and I'll write it over here. Now what I'll do is I'll isolate the Sn. So I'll have 3Sn equals to, just put those terms over there, n cube plus 3n plus 1 by 2 minus n, and right here I can take n common, so I'll do that. I'll have n square plus 3n plus 1, distribute that, you get 3n plus 3 by 2 minus 1. And I'm just going to multiply everything here by 2, and this n2 will go outside. So 2n square plus 3n plus 3 minus 2. So I'll have 2n square plus 3n plus 1. Now, can I simplify this quadratic expression? So you will have to do the middle term break. And you can see that you can make 3n as 2n plus n. So let's just do that. And right here you can take 2n common. So 3 as n will be n by 2, and this will just be 1 into n plus 1, and I can take n plus 1 common, and I'll have 2n plus 1 by 2. But in the next step I'll just divide by 3, so this becomes 2 into 3, 6. And this series was our original this, so therefore we have proved that this series is that by pure algebra. And if you guys done something new, please like and subscribe. Thank you.